Hello, welcome to Physics Meal. Physics Meal is part of Mathematics and Science Meal program, and it's a program designed to help students in the study of physics, chemistry, biology, and also mathematics. It's a wonderful program and has really helped many students as far as the study of mathematics and sciences is concerned. Today on Physics Meal, we are going to look at wave part 2, and we're going to look at the basic terms used in what? In wave. That's what we are going to consider. And basic terms used in wave, there are many basic terms, so we are looking at part 1 of basic terms used in wave. There is need for you to subscribe to this YouTube channel and also follow us on Facebook. Our Facebook page is Mathematics and Science Meal, and this YouTube channel is Mathematics Meal 1. Thank you. Let's begin the beautiful journey on the basic terms used in wave. Now you remember that in our first video when we introduced wave, we took time to look at the meaning of wave as a disturbance that travels through a medium transmitting energy without causing a permanent displacement of the particles in that medium. We were able to discover that during wave motion, energy is transmitted, but you will not transmit matter. And we considered mechanical and electromagnetic waves. We also looked at transverse wave and longitudinal wave, and the terms that are associated with both transverse wave and longitudinal wave. We talked about the issue of equilibrium line, crest, trough. We mentioned compression and rarefactions as it concerns longitudinal wave. So today we want to look at another aspect of wave, the part 2 of it, where we have to consider the basic terms that are associated with wave. So let's look at that. So we are going to look at the first term, and that first term is amplitude. There are so many terms that are associated with wave, and the first one we are going to look at is amplitude. Now, amplitude is the maximum displacement obtained in a wave. The maximum displacement. So amplitude is the maximum displacement. Maximum displacement in a wave motion. That's what we mean by what? Amplitude, the maximum displacement in a wave motion. Let's take, for example, I have this, that. Now, the graph of displacement against time. Now, if you look at this, this is the highest displacement. This is the origin. The particle have been displaced. There is displacement, but this is the highest displacement. The highest. From here to here. That highest displacement or the maximum displacement is what we call amplitude. Amplitude. But these ones are just displacement, but this is the highest displacement in this wave motion. So that highest displacement is the word amplitude. The amplitude. So the symbol for amplitude, we're going to use A, is A. And because amplitude is displacement, we know displacement is measured in meters, so its unit is meters. That's the SI unit of displacement. Its unit is meters. So this one of the important term that we use in wave. One of the important terms we use in wave, amplitude. The maximum displacement in a wave motion, that's amplitude. Now, number 2 term we are going to look at is period. Period of a wave, Period, we know when you do simple harmonic motion and circular motion, you know about period. When you say something is periodic. But in wave, what do we mean by period? We say that period period is the time taken to complete one vibrational cycle, one cycle. Let's say one vibrational cycle. The time taken to complete one vibrational cycle. Now you remember that when we started looking at a wave, we talked about crest and we talked about trough. Now we can also define period in terms of crest and trough. We can say that period is the time taken to complete a distance between two successive crests, or the time taken to complete a distance between two successive troughs. So you take note of this. That means it is also the time taken to complete one wavelength. The time taken to complete a wavelength is what? Is a period. So the time taken to complete two successive crests, or the time taken to complete a distance between two successive troughs, that will also give us what? Period. So period is the time taken to complete one vibrational cycle. That's period. So if I have this, I'm using a transverse wave, and I have that. Now, from here to here, that's one cycle. From here to here, that's one cycle. Now, the time taken to complete this one cycle, that is what? That's a period. So if I have the time, let's say I have 5 seconds here, then these 5 seconds represents the period, because it is the time taken to complete one cycle. This is like half cycle, another half cycle. If you join that, you have a cycle, one full cycle. So the time taken to complete one cycle is what? A period. Also, the time taken to complete the distance between two successive crests. You know, this is a crest, that's the crest. So this time here is also period. This time, distance between two successive crests, the time taken to complete the distance between two successive crests is also a period. The same way, if we talk about particles that are in phase, or points that are in phase rather, the distance between 2 points, the time taken to complete the distance between two successive points in phase is also what? Period. So anytime one cycle is completed, then the time taken to complete that one cycle is what? Is period. I think this is very clear. It is very clear. What it means is that, supposing I have the time from here now, maybe I have that, I have this time, maybe 7.5 seconds, I have this. The implication is that from here to here, this time now is not period, it's just ordinary time. It's not period, because this is not the time taken to complete one cycle. What we have here is 1.5 what? Cycle. That's from here to here. So this 7.5 seconds cannot be the what? Cannot be the period, because it is the time taken to complete 1.5 cycles and not the time taken to complete one cycle. So it's not period. All right, let's move further. The symbol of period is capital T, and the unit is seconds. The SI unit, seconds. Now, if we have many cycles completed in a certain time, we can also generate an expression that will enable us calculate period. So if n cycles are completed in t seconds, then the period will be given by, if we have n cycles completed in a certain time, t seconds, then the period will be given by have an expression. The period will be given by t equals t over n, and call this situation 1, where we have already said that n is the number of cycles, number of vibrations, number of revolutions, number of oscillations if you are looking at simple harmonic motion, and t is equal to time. T is time in seconds. So in a situation where we have the number of cycles given to us is not actually one cycle, and definitely since the number of cycles is not one cycle, the time taken to complete that number of cycles cannot be period. Let's take, for example, if I have this, and I have that, and I have this, and then with this, let's say, I have this, and we have 15 seconds. Now, from here to here, the time taken to cover from here to here is 15 seconds. If you are asked to get the period here, the period will not be 15 seconds, because this 15 seconds is not the time taken to cover what? To cover one cycle. So we need to find how many cycles do we have here. That's it. So we are giving time to be t equals 15 seconds. How many cycles do we have here? We have 1 with this and this 1, this and this 2, and then 2.5. 2.5 cycles, which is 2.5 cycles. So in such situation, we know the number of cycles, we know the time, then we can comfortably find the what? Find the period by just saying t is small t over n. And what is small t? 15 seconds divided by 2.5. And at the end of the day, when this divide this, we are going to have 6 seconds. 6 seconds. And that 6 seconds becomes the period. And if you check it, period is time taken to cover one cycle. So from here to here, it means it took 6 seconds. From here to here, another 6 seconds. Then half of the cycle will actually take 3. So that by the time you add 6 seconds, and 3, you still arrive at the 15. So the period here is 6 seconds. Don't worry, we still have time for calculations involving period and the rest of them. We're going to do calculations in using basic expressions in wave. All right, we have the third term that is very, very important as far as the study of wave is concerned, and that term is what we call frequency. Frequency. That's what we call frequency. That's the third term, frequency. What do we mean by frequency? So, this is the number of cycles or waves completed in a unit time. The number of cycles or number of waves completed in 1 second will give us the frequency. That's in a unit time. That's what we mean by frequency. Number of cycles completed in a unit time. That's frequency. That's frequency. So the symbol frequency is denoted. Frequency is denoted by F, and the XI unit is hertz. That's the XI unit of frequency. The SI unit is hertz. So if n cycles or n waves, number of waves completed, were completed in t seconds, then the frequency F will be given by, the frequency f will be given by f is equal to n over t, and call this equation 2. That's my equation 2. Okay, so the number of waves completed in 1 second in a unit time, that's what gives us the what? The frequency of a wave. The number of waves completed in 1 second gives us the what? The frequency of a wave. All right, so far so good. We have been able to look at 3 terms that are used in wave. One is what we call amplitude, the other one is period, and the third one is frequency. They are all beautiful, very beautiful terms that are associated with wave, and definitely we will be seeing these terms from time to time as we study the concept of wave in physics. We are not yet done. There are other terms that are associated with wave, and when we return in our next video, in part 3 of this video, we'll be looking at basic terms used in wave, part 2 of it. Then we'll see other terms that are very, very important as far as the study of wave is concerned, and definitely you will enjoy it, because I know you are actually enjoying this one. Thank you for watching this video. Make sure you spread the good news about physics meal and about mathematics and science meal, and God will definitely bless you. I love you.